Something I've said many times is that the more difficult or more complicated mathematics gets, the more practical and powerful it becomes. Such is the case in equations called exponential functions, where the x, you've probably never seen these before, where the x is in the exponent. Let's take a look at something like this. Very simple one, y equals 2 to the x. Let's look at the graph and all the possibilities of plugging in various x values into this function. Once again, let me tell you that since the x is in the exponent, we're going to call it an exponential function. Now let's see, for instance, if we plug in a 1, y will equal 2 to the 1th, right? Or 2. And the point 1, 2 is right there. If we put in a 2, y will equal 2 to the 2th, or 4. And you're thinking maybe this is a linear or linear function. But let's put in a couple more points. 2 to the 3rd starts getting much bigger, quicker, is 8. Starting to bend a little bit on you. 2 to the 4th is 16. So we look at the point 4, 16. It's getting very high very quickly, isn't it? Let's go the other way. If we put in a 0, 2 to the 0 power, remember about exponents. Anything to the 0 power is 1. Okay, so we have the point 0, 1. What if we put in negatives? 2 to the minus 1 power. But remember, that's not a negative number. 2 to the minus 1 power is the reciprocal. That's what the negative does. So it's 1 over 2 to the 1th, or 1/2. So let's look at the point back 1, or negative 1, and up a half. Put in a couple more. Negative 2 is also going to give us a non-negative number. It's just going to be a smaller number. It's 1 over 2 to the 2th, or 1/4. So we go back 2 and up a teeny bit, a 1/4. If we put in one more, put in negative 3, do you know what we're going to get? We're going to get 1 over 8, 1 over 2 to the 3rd. Notice that it's never going to get negative, is it? It's just going to get very, very small.
To infinity and beyond.
On the right side, it'll go to infinity. And the left side, it'll get teeny, teeny, but it'll never really reach 0. Now that line that it will never reach,
Are you pondering what I'm pondering?
we have a name for it. Since in this case, anyway, it can never be negative because it can never reach 0, we have a name called an asymptote. Sorry about that. An asymptote, when it never quite reaches it. And that's worthy of remembering because that's going to happen all the time in these exponential functions.
Warning, warning, warning.
Now don't be confused about this never negative idea. For instance, if we look at the same function, but let's add a negative 3 on the end of it.
To infinity and beyond.
That's where y equals 2 to the x. If we look at what y equals 2 to the x minus 3 is, what's that going to do to the graph of the function? Well, it's going to lower it 3, isn't it? So we'll still have an asymptote. And some of these values will be negative, okay? It just will be in a lower place. Okay, but the point is, for these exponentials, it's going to have an asymptote somewhere where it will never really reach the value, will never really reach that line. Interestingly enough, what if we change the location of the negative 3, or minus 3?
Pay attention, son. Look at me when I'm talking.
Let's try putting it in the exponent itself. Well, you know what will happen then? We'll get the same numbers, except it's going to actually be moved to the right.
To
So I take y equals 2 to the x, and I'm going to move these values down 3 actually, and put in some much smaller values actually, and the graph will still move over, but it'll still have an asymptote. Okay?
Just when I think you've said the stupidest thing ever, you keep talking.
Well, what if we looked at an exponential function where the exponent x is a negative number? The new function with the negative exponent is going to look the same as the normal function, except it's going to be a mirror of the normal exponential graph about the y-axis. Something like this. Notice it will still have an asymptote, a number that it will never reach. And these two functions occur very often in real life. The one, the normal if you would, y equals 2 to the x, we call exponential growth. Okay, many things, living things, and hopefully your money, grow exponentially. They don't grow linearly. Okay, and if they get smaller, we call it exponential decay. Sometimes, hopefully, your money doesn't get smaller exponentially, but often many living things, colonies or whatever, get smaller exponentially as well. Okay, so be looking for these in many of the word problems we'll be looking at.
Thank you, Mr. Know-It-All.
That's enough for now.